Hello, I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. The colors and patterns on animals, birds in particular, are nothing short of extraordinary. But those traits can reveal a lot of crucial information, which researchers are working to find. Evolutionary biologists at Princeton University are now enhancing their study of bird plumage with hyperspectral imaging, an approach that provides very detailed spatial and spectral information. The team's study has focused on birds of paradise, specifically the King of Holland's bird of paradise, a rare hybrid that's a cross between the king and magnificent bird of paradise breeds. In their work, the team captured images in the 325 to 700 nanometer range to see more precise features, including those that are invisible to the human eye. The team also paired hyperspectral imaging with photogrammetry, a technique in which hundreds of images are essentially stitched together to create 3D models of the birds. This provided new information about how the bird's coloration impacts and interacts with aspects like morphology. The team says their combined imaging approach will allow further study of evolutionary properties, courtship displays, and warning coloration in birds and potentially other animals. The European Commission is investing 15 million euros to boost photonics technologies. Part of the existing PhotonHub framework, which funds photonics innovation projects, the 15 million euro investment will provide expert support, fast-track access to Europe's leading laboratories, and generous subsidies. The initiative, called the PhotonHub PHACTORY, is meant to essentially help level the playing field, lowering the barrier smaller companies often face with R&D projects. Representatives say the new PhotonHub PHACTORY will be a one-stop shop for photonics innovation. In other investment news, Lumai, a UK-based AI accelerator startup that develops optical computing technology, has secured more than $10 million in funding to aid AI and data center processing costs, performance, and sustainability. A spin-off of the University of Oxford, Lumai's work addresses AI computing limitations using optical processing to accelerate large language models and other transformer-based AI. Company officials say the funding will help further advance product development and will help expand both the company and its U.S. presence. Terahertz imaging is a common technique in the medical realm, and now researchers in Japan are taking it even further. A team at Waseda University has designed a 3D terahertz near-field imaging technique to examine the cochlea, a spiral-shaped organ in the inner ear that converts sound waves into neural signals. This non-invasive approach provides micron-level imaging for a more detailed look at the internal cochlear structure. Given the delicate cochlea's position in the ear, it's difficult to see with conventional imaging methods, which can only get down to millimeter focus sizes. In the Waseda team's study, involving a mouse model, they used a terahertz point source with a diameter of just 20 microns to detect terahertz waves that reflect from inside the ear. They could then reconstruct detailed 3D images and view the sample in cross-sectional slices, similar to a CT scan, to clearly see the cochlea's tiny internal structures. The researchers say they are continuing to enhance their technique to better understand hearing impairments and ultimately detect them sooner for more effective treatments and outcomes. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.